Hi, this is Mrs. LaBarbera. Now we are continuing on applications of Newton's laws. Here is an example from 2007 Mechanics C, question number 1. A block of mass m is put along a rough horizontal surface by a constant applied force of magnitude F1 that acts at an angle theta to the horizontal. The acceleration of the block is a1. Express all algebraic answers in terms of m, f1, theta, a1, and fundamental constants. By the way, fundamental constants basically means G. Okay. Question number 1. On the diagram, draw and label a free body diagram. Show all the forces acting on the block. So we know there is definitely a gravity. We know there is applied force F1 at an angle theta here. There is also a normal force, so we label it N, and then there is a friction force, is opposite of your motion. Question B, derive an expression for the normal force exerted by the surface on the block. So whenever you have to determine a force, first you have to set the coordinates. Since the block is moving to the right in the horizontal direction, so my coordinates to the right, I have positive x, and the vertical is y, upward is positive. Now I just have to resolve all the forces into x and y components. This is also convenient because there is only one force, F1 is at an angle. So all I really have to do is to resolve F1 into F1x and F1y. So here are the direction force in the x direction, force in the y direction. F1 in the diagram, so from here F1x equals F1 cosine theta is because Fx, F1x is adjacent to theta, F1y equals F1 sine theta. And we know mg has no x component, has only y component, which is in the negative direction. F, on the other hand, has no y component, has only x component, also in the negative direction, mu times n. And n has no x component, it has only positive y component. So we know when we add all the x together, that should give us the net force that gives us the acceleration in the x direction, which is a1. And all the force in the y direction should cancel out. So from here, since all the y direction cancel out, so we have F1 sine theta minus mg plus n equals to 0. From that expression, you can get n equals mg minus f1 times sine theta. Next question, derive an expression for the coefficient of kinetic friction mu of the block and the surface. With the given quantities, we know the acceleration of the block, so we also know the n. So from there, this is from the last one, we know the net force in the x direction gives us a1. So from there, F1 cosine theta minus mu times n equals ma1, and n equals mg minus F1 sine theta. So from here, we can solve for mu. To solve for mu, we subtract ma1 on both sides, and we add mu times mg plus F1 sine theta on both sides. In this case, I have isolated mu. And to solve for mu, I simply divide mg minus f1 sine theta on both sides. Next question, on the axis below, sketch graphs of the speed v and the displacement x of the block as a function of time t if the block starts from rest at x equals to 0 and t equals to 0. So we know in this case, acceleration is constant because net force is constant. So in VT graph, we know slope is acceleration. Since acceleration is constant, slope should be constant positive. So that's V versus T. In the X versus T graph, the slope should give you the information about V. Actually, it gives you the information of the slope of V. So the slope of the graph should be positive increasing. So that should give you a parabola. E. If applied force is large enough, the block will lose contact with the surface. Derive an expression for the magnitude of the greatest acceleration A max that block can have and still maintain contact with the ground. only in terms of theta and fundamental constant. That means you can be in terms of F1 in this case. So let's take a look at the forces we have learned. We know N equals mg minus F1 sine theta. We know F1 cosine theta minus mu times this N should be equals to ma1. When a block loses contact with the surface, N equals to 0, so the second term is gone. So that means m times a max should give you F1 cosine theta. But in your answer, you shouldn't have F1. So you have to find F1. How do we find F1? We go from the first term. So again, when the block loses contact, N equals to 0, and F1 cosine theta equals to max. From N equals to 0, we get F1 should be equals to mg divided by sine theta. From the second equation, we can find a max, which is F1 cosine theta divided by m. What is F1? F1 equals mg divided by sine theta times cosine theta divided by m. M and m cancels. Cosine theta divided by sine theta give you cotangent theta. So A max equals to g times cotangent theta. That's it for this question. Thanks for watching.